Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Docker Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to continue with finding equations of tangent line and normal lines at a given point. So this is question 4, 5, 6, 7. If you did not watch the previous lesson, please, I urge that you go back and watch the previous lesson before continuing with this, so that at least you have the basis under finding the equation of the tangent and the normal line. But even if you did not, we will still help you in the process. But it's advisable that you follow the lesson trend and be on path so that you don't miss some basic concepts. So question 4 says, y equals sine of x times y. Now, we know that whenever we have x times y, to differentiate that expression, we must use the product rule. So our objective first is to find the slope. We first need to find the slope because since we are finding the equation of a tangent line, we know that the equation of a line at a given point is just y equals to mx plus b. So we need to find m and we also need to find b. So the first target is to find m. And we know that m is also called the derivative, the first derivative. So we find the first derivative, y prime equals the derivative of sine of x, y, or the derivative of sine of any angle is just equals to cos of that angle. Then you find the derivative of the angle after differentiating that angle. You differentiate the angle. So the derivative of x, y, since there is a product rule, we hold on to, the rule says we must hold on to the first factor or the second factor. So we hold on to the first factor and we differentiate the second. The derivative of y is just 1, but we attach y prime since y is the name of the function. Plus. So in the rule we have plus. We hold the second function now, the function that we differentiated first, we hold it in the second expression and we differentiate the previous one. So the derivative of x is 1. So we don't necessarily have to write 1. Now we can simplify. Now we multiply x y prime by this trig function and y by this trig function. We don't multiply the angle. Now also we don't necessarily need to multiply this expression by this expression. We don't. It might just give us long work. What if you had a kind of long expression? You wouldn't have been, carrying on that long multiplication. So since our objective is to only find the slope, what we need to do is to just replace x and y with their value. That's all. Just replace x and y with the value and be able to solve for y prime. So what is x? Since the point is pi by 2, 1, so this is our x. X is pi by 2, and then this is our y. We know for every other pair, the first is x and the second is y. So we have y prime equals cos of x pi over 2, and then y is just 1, times x pi by 2, y prime plus 1. So what is cos of pi by 2? Because pi by 2 times 1 is just pi by 2. What is cos of pi by 2? If you look at this cycle, this is 0 degree, this is 180 degrees, this is 90 degrees, this is 270 degrees, and coming back, this is 360 degrees, and so on, right? Now, this is a unit cycle. We have 1 minus 1, 1 minus 1. For the x-axis, cos of 0 degree, all angles that falls exactly on the x-axis, cos of those angles will either be positive 1 or negative 1. If it falls on this side, cos will be positive 1. If it falls on this side, cos will be -1. If it falls on the y-axis, cos will be 0, and then sine will be +1 or -1. Likewise with the x-axis, any angle that falls on this axis, sine will be 0. That's why sine of 0 degree is 0. Sine of 360 is 0. Sine of 180 is 0. You can use your calculator and verify. And then on this side, cos of 90 is 1. Cos of 270 is -1, and so forth. Let's say sine of 90 is 1, and then sine of 270 is -1. But cos of 90 is 0, cos of 270 is 0. So for all quadrantal angles, cos of those angles that falls exactly on the x-axis is either 1 or -1. And for angles that falls exactly on the y-axis, sine is either +1 or -1. For this pi by 2, in radian measure, if you want to convert this pi by 2 to degree, pi by 2 to degree, you can say this times 180 all over pi. So pi will cancel pi. 2 into itself 1 times, 2 into this 90. So pi by 2, when it is converted to degree, it is 90 degrees. So what is cos of 90 degrees? Cos of 90 degrees is 0. So based upon that, we have this to just be 0. So it's y prime equals, this is 0. So because this is 0, this entire thing goes to 0. You don't have to continue. So if y prime, which is now the slope, if the slope is 0, it means we can find now the equation of the tangent line. So y equals to mx plus b. So what do we have? We have m to be 0, and then we have b. So we don't know b yet. So let's find our b. So y is 1, and then this is 0. So plus b. So b would just be equals to 1. So if b is 1, it means y is equals to, this is mx. M is also already 0, so this is 0. So y is equals to 1. So we will have the equation of a tangent line to be equals to 1. Now, what will be the equation of the normal line? We need to find the equation of the normal line. Can I erase this? Now we told you that the product of two slopes is equals to -1 if and only if those two lines are perpendicular lines. So since the tangent line is perpendicular to or the normal line is perpendicular to the tangent line, since that is the case, these two lines are perpendicular, tangent and normal lines are perpendicular. It means the product of their slopes must be equal to -1. Now, what was the first slope? The first slope, which was m1, was 0. So 0 multiplied by m2 is also 0. 0 is equals to -1. The fact that 0 is not equals to -1, thus the equation of the normal line will be undefined, because we cannot determine the equation of the normal line, since we've seen that the slope is equal to 0. So let's do the next problem. So the next problem says y equals to x plus cos of xy. So again, we find the first derivative. So y prime equals derivative of x is 1. The derivative of cos is minus sine of that angle, and then you differentiate the angle. So using the product rule, we hold x, differentiate y, we get 1. But since y is the name of the function, we must attach y prime according to the methods of differentiation under implicit differentiation. So it's in the previous lesson. Please watch if you are a bit confused on how we are attaching y prime. Plus, we hold y now and differentiate x, we just get 1. So we can again just replace x and y with its value, or if you want to solve for y prime, that's just a long way. You can still solve for y prime first. It's just a long way. So we multiply x y prime by this. So you don't multiply the angles. So we have x y prime sine of x y, and then x, let's say y times this expression is also negative y sine of xy. So the terms with y prime, we must put them one side of the equation. We have y prime plus, this one goes across, it becomes plus xy prime sine of xy equals 1 minus y sine of xy. So there's just a long way of doing the problem. So we can factor out y prime, and then we'll be left with 1 right here plus xy, let's say x sine of xy, all equals to 1 minus y sine of xy. So we can now divide both sides by this expression. We will have y prime now to be 1 minus y sine of xy, all over 1 plus x sine of xy. So this is actually the long way of doing it. Now we need to find the value for the slope, because this is the slope. So we know that x is just 0. This is x, 0, and then y is 1. So because x is 0, the point is 0, 1. So x is 0, and then y is 1. So we got to replace x with 0. So y prime is equals 1 minus this y is 1. So it's just sine of xy. So x is already 0, so that whole thing goes to 0. 1 plus x sine of xy. So it's also 0, right? So that whole thing goes to 0. So x is 0. So you already know that this term goes to 0. So what would be our slope? Our slope now is equal to 1 minus sine of 0. Now we told you from what we just did, 0 degrees. So sine of 0 degree is just equals to positive 1. And then cos of, let's say sine of 0 degree is equal to 0. Because on this line, cos is positive 1 or negative 1. Sine is 0. On this line, sine is positive 1 or negative 1. Cos is also 0. So sine of 0 degree is equals to 0. So this is just 1. This also, so it's just 1 over 1. So the slope is now equal to 1. Since the slope is equal to 1, we can now determine the equation of the tangent line and the equation of the normal line. So if m1 is equal to 1, it means m2 will be equal to the reciprocal. Find the reciprocal of this, that is turn this around. 1 over 1, the reciprocal is just 1, right? And then you attach a negative. Or if you want to do it, you can say m1 times m2 equals to minus 1. So m1 is already positive 1. So since m1 is positive 1, m2 will just be minus 1. So this is for the normal line, and this is for the tangent line. So let's find a tangent line. So we have y equals to mx plus b. So we know that m is already 1. So we need to find our b. So let's replace y and x. So what is y? Y is 0. Y is 1. X is 0. So this is 1. This is 0 plus b. So b is equals to 1. So y now equals to mx. M is 1. So it's just x plus b is 1. So this is now our equation of the tangent line. For the normal line, y equals to mx plus b. So to find b, replace y with its value. So y is 1, and then this is 0 plus b. So b is also 1. So y equals to mx plus b. Y now will be m is minus 1. So it's just minus x. B is 1 plus 1. So these are the different equations, the tangent line equation and the normal line. So let's do the next one. Let's do the next one. So the next question says, question 6 says x squared plus y squared raised to the power 3 equals to 8x squared y squared at minus 1 comma 1. So again, we differentiate. For this problem, whenever you notice that you have an expression within and then it's raised to a power, whenever an expression is raised to a power, just know that you must apply the extended power rule. That is, you bring this power down, subtract 1 from this power, and you differentiate with inside. So we bring this power down, is 3. We rewrite what is in. We subtract 1 from this 3, it gives us 2. Then we differentiate inside. The derivative of x squared is 2x. The derivative of y squared is 2y. But y is the name of the function, so we must always attach y prime. Equals. Now, this side you have x and y being multiplied. So we must use the product rule. So the product rule says we hold the first one and we differentiate the second. So the derivative of y squared gives us 2y. Then we attach y prime. Plus, we hold y squared now and we differentiate x squared. We get 2x. Right? So we can simplify now because our objective is to solve for y prime. But there's no need of solving for y prime first. What we can do to make this thing much easier for us, we can replace x and y with the values. Because even if we solve for y prime, our objective is to find the value of y prime, which is the slope. So in finding the value of y prime, we will have to replace x and y with these values. So no need of, allowing us to go through the tough times, and then at the end of the day, we still replace. So let's just replace now, and we will see that as we go along, the problem will be reducing and will be getting easier for us. So where's where we see x, we put minus 1. So it's 3. X now is minus 1 raised to the second power. Y is positive 1. And positive 1 raised to the positive, let's say to the second power is just positive 1. Positive 1 raised to any power is positive 1. So it's just 1, right? This minus 1 raised to the second power means minus 1 times minus 1. This is not minus 1 times 2. So negative times negative is positive. So this is also positive 1. Then move on the next area. 2 times this x is minus 1 plus 2 times y. Y is positive 1. And then times y prime. 8. Now, x minus 1 times minus 1 is positive 1. Times this 2. So you have 2. This y is 1. So it's just 2y prime. I use parentheses. Then this y is 1 square. This is negative. So this is 2 times negative 1. So it gives negative 2. Right? Great. So we simplify further. 1 plus 1 is 2. 2 2 times 3 is 6. This is minus 2 plus 2y prime. This is 8 times 2 is 16, right? And then 8 times 2 is also 16. So 6 times 2 is 12. 6 times 2 is 12. There is 12 plus 12 y prime. And then equals to 16 y prime minus 16. So what can we do? We need this and this to be together. So we send this 16 across. So it's 12 y prime minus 16 y prime. This is 16. And then this 12 goes across. So it is 16. Okay. Is it 16y? What is it? Okay, this is 16. So this 12 goes across, it becomes minus 12. So y prime is being factored out. You have 12. Or so it's 12 minus 16, right? It's 12 minus 16. What is 12 minus 16? It's minus 4 y prime. So there's 16. Is this positive 16? So let's go over it before we make some mistakes so that we don't get ourselves confused. Let's go over it, right? Okay, this one is minus 12. So 6 times 2 is minus 12. So if this minus 12 goes across, it becomes positive 12. So positive minus 16 plus 12 is minus 4. So we divide this out by minus 4 and by minus 4. So y prime now, which is equals to the slope, is just equals to 1. So if the slope is equal to 1 for the tangent line, it means the normal line, the slope will be minus 1. So since the slope now is equals to 1, we can find the equation of the tangent line. That is y equals to mx plus b. So we can now find, now the point is minus 1 comma 1, right? So this is x, this is y. So we can replace x and y to find b, and also replace x. Let's say replace m. So y is 1, m is 1, x is minus 1 plus b. So minus and this 1 gives us minus 1. You send it across, it becomes plus 1. So b is equals to 2. So y equals to m is 1. So it's x. And then this b now is 2. So this is the equation of the tangent line. For the normal line, we have y equals to mx plus b. So the slope for this would just be equals to minus 1. So we have y now is 1. And then this m is minus 1 times x is minus 1 plus b. This is positive. It goes across, it becomes negative. So b is equal to 0. So y equals to m is minus 1, which is just minus x. This b is 0. So the slope of the normal line is y equals to minus x. So let's solve the last problem. And then we will be done for the topic under equations of tangent and normal lines at a given point. Next will be higher order derivatives. So we solve question 7. We have x squared plus y minus x raised to the third power is equals to 9 at x is equals to 1. So we differentiate, right? The derivative of x squared is just 2x. We use the extended power rule. We bring this power down, rewrite what is in, reduce the power by 1, and differentiate inside. The derivative of y is 1, but we attach y prime. The derivative of x is just 1. And then all equals, derivative of a constant goes to 0. So we can now replace Okay, so we can now simplify, right? Because we need to find, so they only give us 1 point. X is equals to 1. So we have 2x plus, let's simplify this one right there. So we have to expand this. So it's y minus x times y minus x, just to do it in the simplified form. So what do we have? We have y squared. So it becomes 3y squared of this 3. And then what's next? Y times x is minus xy. X times y is minus xy. So this and this will give us 2xy. And this and this will give us positive x squared. So it's y squared minus 2xy. So multiply by 3. So 3 times this is 3y squared. 3 times this is minus 3 or minus 6xy. And then 3 times x squared is just 3x squared, all equals to 0. So what is x? X is 1. So we replace x with 1. Oh, sorry. We just expand this. So we must multiply it by y prime minus 1. So we have to multiply. So it's 2x. So the first one is 3y prime. And then 3y squared y prime. And this is, so what we just need to do is to just, because this is just y prime, right? So we just need to attach this y prime to this whole thing. So which is 3y squared minus 6x y plus 3x squared. Then we just attach y prime to it, right? And then we multiply this negative by this entire expression. It gives us negative 3y squared, positive 6xy, and then negative 3x squared, all equals to 0. So we make sure that this term remains on this side of the equation. So it's 3y squared minus 6xy plus 3x squared times this y prime. We send this one across. So what do we have? We have positive y squared, 3y squared, minus this one goes across, minus 6xy, positive 3x squared, and then this 2x is minus 2x. So we divide both sides. We just have y prime to be. So let's go 3y squared plus 3x squared minus 6xy minus 2x, all over 3y squared minus 6xy plus 3x squared. So what we can do now, we can replace x with 1, because we were told that x is equal to 1. So if we replace x with 1, we have y prime to be, this is 3y squared plus 3 times 1 is just 3. So this is 6xy. So what happens? This x is just 1. So it's just 6y. This x is also 1. So it's minus 2. And then down here you have 3y squared. This x is 1. So it's minus 6y. And then this is 1. So it's positive 3. So this and this. So we have y prime equals to 3y squared minus 6y. And then this gives us plus 1, all over. We can decide to factor out 3, whatever the case might be. If we factor out 3, we will have, this should be y squared, 3 into 6, 2 times 2y, and then plus 1. So let's see. So if we factor out the numerator, Let's see as to whether we can factor out the numerator. So for the denominator, you can have y times y give you y squared, and then two expressions you can multiply to give you positive 1. When you add them, you will get minus 2. So we know that negative 1 times negative 1 is equal to positive 1, and then negative 1 plus negative 1 is equal to negative 2. So it's negative 1 and negative 1. For up here, we can say 3y, and we say y. We can use some try and error methods. So this is 1 and 1. So we see as to whether we can get this middle term, which is this guy, which is a 6y. So 3 times this gives us, okay, so 3 times this. So we cannot get this 6. Can I get this 6? We cannot get that 6. Let's see as to whether that problem was correct as given. Okay. Okay, so this is the slope